I'm Eric Ferraiuolo. I'm going to be talking about the YUI App Framework today. If any of you were in Luke's talk yesterday, he was talking about the building blocks of building classes and different things with YUI, and he sort of ended at MVC stuff. And we're going to kind of continue from there in my talk and talk about some of the stuff we're doing in the app framework. And so the first thing I wanted to get to was MVC. And MVC is a pattern of breaking apart your code that seems to be very common in especially GUI environments or user interfaces. And the idea, model view controller, how many of you are familiar with the MVC concepts? Everybody. Awesome. Just to touch on maybe why you'd want to do this in a web application UI, you can separate out your data from your rendering. One of the main things you could think of is a common example. You have a username displayed in the top right corner of the page, and say in the main content area of the page, and then you have a UI for the user to update their name. And when they go to update their name, you may have to write a procedure that basically says, okay, go store that on the server, then go manually update in the top corner and manually update it in the main area of the page. And this is like a very tight coupling and leads to refactoring problems, and it doesn't really separate the concerns of what you're trying to build. So the app framework is an MVC-ish like framework to help formalize these concepts inside of YUI. So I wanted to point out that Backbone is a really awesome MVC-ish library for client-side and server-side somewhat to implement these techniques. And it's a very elegant, simple approach. It does some interesting things with respect to models and views that we found to be excellent. And so we wanted to follow their lead, but there was a lot of things we already had in YUI. We already have Y.Base, we already have attributes, we have node, and like just trying to figure out, well, we need to formalize these concepts, and we already have all these good underlying utilities. Let's see if we can sort of follow the lead with Backbone, which has been getting a lot of steam, but have something in YUI where you don't have to use multiple libraries. If you wanted to do MVC-like stuff in YUI, you don't have to include Backbone, which requires underscore and jQuery and stuff. We had everything already for the requirements. So the first thing I wanted to talk about was just the model, and in particular, Y.Model, and maybe some of the things that model is doing. Like I mentioned, we already had base, and base has attributes and custom events, but there's some things that model does, Y.Model does, to help you focus more on a class that is for dealing with your data. So one thing that is common against any type of MVC framework is that the model has its data is observable. So anytime there's a change in the data housed in the model, there's a change event fired or something. So we wanted to make sure we have that, but that's already part of attribute. So the thing that we add in Y.Model is this coalesce change event. So if multiple data attributes are changing at once inside the model, one high-level change event is fired. So that works out really well for being able to have a UI to respond to that one event and, say, a view re-render itself. We also added this idea of a sync layer inside of model. And this is so that you can sync data between, say, a server and the client, and have your business logic around that syncing. So if you're doing any type of validation of cross attributes before you go and save that to the server, or you need to load data from the server, that's what the sync layer handles. And there's another thing that we added around dealing with models, which is model list. And model list basically adds collection semantics to working with a set of models. The interesting thing that we do in Y.Model list and Y.Model is that a model can exist in multiple lists. And these lists are usually used to help you work with your data. They have nice methods for traversing iterating over the collections, and they can be ordered. They have some nice conveniences for loading a set of data from the server into a model list, and it will automatically create the model instances for you. And you could think of, like, if you're working with a page set of data where the data is like broken up into separate pages, and maybe you have like I don't know, a list of users, and then you're looking at page 1, and then you go to page 2. You can imagine a model list being used to represent the current working set that you're looking at. So like I'm looking at the first 10 users, and then I can reset the model list with the 11 through 20 users. And one thing that we also added is using the custom event infrastructure in YUI. If you call set, say I'm calling set on this 4th model in the list, any events like the change event that would fire from setting some data attribute there will bubble up to the list. So you can just listen on the list for any changes. And this is really nice because you don't have to worry about what's inside the list. You just know you have this list, and anytime there's a change on one of your foo models, you can respond to that. So one of the other components in the app framework is view. And the view is a renderable chunk of your application. And it has an idea of a container. And that container is used, and the view instance is using that container, and it will deal with rendering stuff inside of it. And the thing that we have is Vue doesn't really contain much logic. It's more of a code organization tool, but it has some conveniences as well. So one thing that a Vue has is a render method, but what the contract is you have to provide the implementation of that. There's going to be no prescribed rendering of your Vue. The same goes for templating. There's hooks in there for you to provide your template, but it's really up to you to choose. So it doesn't force you into using any particular type of templating or any particular type of rendering. It's totally up to you. But what it does have that's nice is a way for you to declaratively define your events around that particular chunk of your UI. And this is really nice because it uses event delegation and allows you to declare up front that if a particular node in your view is clicked on, that you can respond to that. So this makes it really powerful, and also helps you work with your models. So a view can be instantiated and passed in a model instance, but it doesn't have to, or it can be passed in a model list. And that's commonly what they're used for, but you can use views to just break apart your different, your rendering hierarchy of your page. It's also a very lightweight class, and like I'm saying, it has some conveniences for you, but it's really left up to you to implement the rendering of your views. So the other component that we have is router. It used to be called controller, but the view works more like the controller in the YUI App Framework. And so it was basically a poor naming decision we did in 3.4. And so we've renamed it to router because it's basically used for a navigation management, for dealing with changes in your URL and responding to those. So if you have a single page application, but you want to have bookmarkable URLs, router is a good thing to use for that. It will seamlessly deal with older browsers by using hash-based URLs. So you can imagine a URL that example.com/hash/ some URL, some path, And it can seamlessly upgrade and switch between the two. So if you're on an IE browser, you would have that version. But if you're on Chrome, Firefox, Safari, or iOS too, you would get the nice HTML5 push state and full URLs. So the way that the HTML5 history APIs work is you can add history entries which will change the full URL, the full path, without causing a request to go off to the server. And then accompanying that is a pop state event, which is used if the user is hitting the browser backwards or forward button. A pop state event occurs, and you can listen for that and re-render the state in your application. So I wanted to show the router's somewhat more complicated, or maybe something that people haven't experienced before, so I wanted to go over it in a little more detail. Here we have a basic example of sort of the simplest router you could do that actually did something interesting. So at the top here, I'm just instantiating a new instance of a router. You can also subclass router. It's meant to work either way. In this case, I'm just going to create a new instance. And I'm telling the router to route any path that is /library/ and then this lib here is like a placeholder or a variable you could think of to this callback function. This callback function then is passed a request object. And what I can do is look at the parameters of this request object, which include this placeholder lib parameter from the URL. So I can get a reference to that. And then in this case, I see if the library equals YUI, then I can just say log out to the console that how awesome YUI is. And then to have this route be dispatched, or to change the URL and then have the router call into my callback here, you can call save. And this will save a new history entry and update the URL and dispatch to any route handlers that match. So in this case, my route handler does match, and it will print out YUI is awesome. YUI library is awesome. So we already had a history manager in YUI, but router adds a little more to it, and it actually uses history under the hood. So it actually has an instance of history. But what this helps with is normalizing the two different ways the different ways that the history or the URL could be changing. So like I mentioned before, the pop state event is in the new fancy HTML5 history browsers. When you hit the forward and back button, it gracefully degrades to using the hash change event, which exists even in IE. But then also when you call save and replace on the router, the API method save and replace, it will call into history and call push state. But all of these things together end up firing this history change event. And so the router is listening for its history instance to fire this change event. And when it does, it goes ahead and dispatches to the route handler that matches, the first one that matches. So it's nice that all this is baked in for you, because otherwise people would be just writing this type of thing over history all the time. So far I went over what we have in 3.4. And what's nice is we had all these components already, and we just formalized these concepts using them. So the model list, view, and router all only came out to 4.6 kilobytes of new code into the library to have all this functionality, which is really great. And the other thing is, as we were developing these app framework components, there were people who were literally using what we were pushing to GitHub. Like right after we pushed it to GitHub, people started using this. So it was great to see how well received all this was with the community. And it really showed us that people did actually need this type of thing, this formalization of these concepts, this way to help guide them in structuring and breaking down their applications. But we're not stopping there. And so next I'll go into what we have coming. And by the way, coming is actually really soon, because a lot of the stuff I'll be talking about now is already on GitHub. And we have our first PR of 3.5 will be next month. So this stuff will be coming out next month. And the official GA release of 3.5 is scheduled for Q1 of 2012. So Y.App is the big thing. And what it provides is, you could think of Y.App as a view and navigation manager, but also a place for you to really start hanging your application off of. It's a really great starting point. It's a high-level component for you to be able to start building these rich UI applications. And I just wanted to start off with a super basic example application. So imagine this is a user's app. Similar to Router, you can instantiate Y.App or you can subclass it. You will probably end up subclassing it for anything that's not trivial. So the one thing that it does here is it allows you to declare your main application views of your application. You could think of these as like the different pages. And the first one is this users view. So in this application, we would have a list of users on one page, and you could click on a user and then see the detail of a particular user and be able to go back and forth between those, all say doing this on the client. So in this case, we're specifying a type, which is our users view subclass, and we're telling it to preserve any view instance it creates for this users view. Because you can imagine if we have 100 users, we don't need to necessarily re-render the DOM for that every single time. So this is one option where you can specify to preserve a view or not. And then we have this user view. And this is used to render details of a particular user, say. But we can specify a hierarchical relationship between these two by saying that the parent for the user view is the user's view. And this way we can do nice sliding transitions between these things. And then to look at the code here, the most basic thing you could do with this. So imagine at the top here, I have a new users list, which is a model list of my user data. Imagine that's filled out. And I can use the same routing stuff that you just saw in Router. So I can say that I want to route /user/ to this handler here. And for this handler, I want to show the user's view. And what I want to do is pass to that view my list of users so it can render it out. Or if it's already rendered, just redisplay it or transition to it. And then one that's a little more interesting is the user view. Here, again, I have this placeholder for the ID. So I can go ahead and look at my users collection, and I want to get the specific user model instance out of it. So model lists have this method on them, get by ID, and the ID is on the request parameters object. So now I have a reference to my user model instance. And then I can say show view, the user view, and this doesn't preserve the view instance, so it'll create it new every time. And in this case, I want to pass it the model of the user that I would like it to render. And then I can be called back after, say, the transition has completed, if you were doing sliding transitions or something, to do anything else that I may need to do. So this is like the most basic type of application you can do. And this is all around managing the view, your views and the life cycle of these views, dealing with instantiating them, transitioning them. But then there's a little bit more that it does too. Baked into Y.App is this idea of enhanced navigation. And what I mean here is we've all seen this on GitHub. They have this really nice source tree browser. Now, the URL, if you watch up there, is actually updating. It's the full path. It's not just a hash fragment. And they're transitioning in this content. It's really nice. It's fast. The back button still works, and it's switching the URL. And this is just like a nice enhanced experience. And GitHub wrote this correctly, because if I just go up to my URL bar and refresh the page or send somebody a link to that, the server will handle that request and render the entire page. Where here, it's just going off and fetching a little snippet of content and showing it and transitioning to it. So the GitHub developers actually named this technique, and it's called PJAX, which is push state, meaning the HTML5 push state history API to update the full URL, plus AJAX, where AJAX there meaning like dynamically loading and rendering content. So how it works is basically you're handling a link click, and then you can, instead of letting that request or that click bubble up to the window object and then having the browser go and send the request for that URL to the server, you can prevent that from happening and instead call into the history push state API to update the full URL and then go and fetch your content, maybe say over XHR, to grab the little snippet of content that you want to show in. So that's the basic idea. The one thing we realized, though, is that the AJAX part of push state does not necessarily mean just XHR. You may already have the data sitting in the client, like in a Y.App instance or something, and you may not need to go to the server to do it, but this idea of like dynamically rendering the content is the important part. And of course, it maintains the browser forward and back buttons, and it's really like a seamless upgrade. So IE browsers just get a full page refresh, but any newer browser gets this nice enhanced experience. So we actually created a Y.PJAX module. And it's not necessarily under the app framework set of components, but it's used by them. So PJAX base is an extension that is meant to be mixed in with router subclasses. And PJAX base handles the link click events, and what it will do is it'll look to see does the router have a route for this URL? Can the router service this request, or does it have to go off to the server? So that's what PJAX base is main functionality is. But then we mixed these things together and created a Y.PJAX as well. And this is an instantiable class. There's also a Y.Node plugin as well to make it even simpler to use. But the basics here is it's just doing a convention. It's using PJAX base. It's mixing it into router, but it just has a specific convention that it's using, which is that the router the PJAX has a route for star, so that matches everything. And what it says is that all link clicks will then go to the PJAX class's navigative method. And what that will do is update the URL, make an XHR request to the server using that URL, adding additional headers so that the server knows that it's a PJAX request. And then the server can respond with giving, say, a rendered snippet of the page or data or something back. And then it will automatically go and set that content into some container in the DOM. So I just want to recap what Y.App is. So it actually is built up using a view. So it mixes in view, router, and PJAX base together into one class. So it gives you your containment and rendering of view. It has the URL handling of router, and it has this enhanced navigation that PJAX adds. But it also has this idea of an active view. So like, which page am I currently looking at? And it deals with managing the lifecycle of those views, those page views, and transitioning between them. And you can instantiate it, subclass it. So one of the other things we've been thinking about and working with the NYUI and then for 3.5, and this is also has a really big use with the app framework. You would use this a lot, which is templating. And so YUI has this string substitution templating, but we wanted to go a step further, and we've adopted a mustache-based templating for YUI, and specifically we're going with handlebars here. Dave mentioned this in the opening keynote. And I just wanted to go over a couple details about this and show why it's cool and interesting. So here's a very basic handlebars template. This is using a script element with a more or less fake MIME type here, so that the browser will not interpret this as JavaScript. It's more of just a placeholder to put content that is not code. But it has an ID, which is important here, so that we can reference it later. So in this template, say this is just some entry, like a blog entry or something. We have a title. It has these very basic conditionals and looping, which are nice. So if there's an author for this blog entry, we'll just go ahead and show the author and also print out the body. And then working with this from the JavaScript side is we made Handlebars a first-class YUI module. So this way you can say, use Handlebars. And in this case, we're using Handlebars and Node base. And what we can do is that template on the previous slide, we can reference it by ID, get its content, will just give us a string back. And then Handlebars has this ability to compile a string template into a function, which you can use to pass data into, and it will render the placeholders, or put the data in the placeholders. So we're creating this render function here, and then we have this entry, which we can then go ahead and render into some container. So this is very useful when you're developing applications to be able to have something like this. But one of the other things we're thinking about and working on is making sure that YUI runs really well on the server, and particularly on Node.js. And so Handlebars is also runs in a Node.js environment, which is really nice because we want template sharing between your client code, your server code. You don't want to have to write your templates twice or in 2 different languages. So this is a big thing here. Also, we want to make sure that models can be shared across the client and the server, that your the router or the app can be shared between the client and the server. So just trying to get as much code sharing as possible. So with YUI and Node being a first-class environment for YUI, we're definitely thinking about all these things and working on making sure that there's as much code sharing possible between the client and server side of your applications. The other thing we're doing is we're working on guides to help show how you can use these tools, how you can use the app framework components to actually go through and look at how we envision applications being built using responsive design techniques, working well on mobile devices, code sharing with the server. So we're also going to be developing these types of guides to help people get started and see our vision of how applications can be built with this stuff. So now I have a little demo app, which is actually using the app framework and even the new stuff I've been talking about. And you guys can feel free to load this up on your phones. I've only tested it on the iPhone and iPad, but I know it definitely works on there. So go ahead and launch this up. If you have an issue, this is using geolocation, so you may need to enable the Safari on your iOS device to allow location, but I'll go ahead and look at it too. All right, so this is the whole point of the app is just to find interesting photos near your current location, and this definitely found some interesting ones. And so what happens is the app starts, it figures out your location, it actually updates the URL up here to be the location so that you could send this off to somebody else. For example, I have one of from Boston, near where I live, and so I can just refresh this page, and it has all the photos near Boston. So it's nice. There's these permalinks for these photos. And so if we look around here, we can just see this list of photos here. It kind of does an infinite scrolling thing, so it'll load more. This is using YQL and Flickr. So all of the models that I have are backed with YQL. I'm not sure why it's not loading. But I can go ahead and look at some of these photos if the internet works. There we go. So this shows the large version of it. It updated the URL to include /photo/photo ID. It's nice you can use the arrow key to go between them, that sort of thing. And I can come up here, just refresh this page, and it should reload the state as long as the internet's fast enough from where I was before. Imagine it worked. Is it working for people?
Yeah, it is slow.
It's slow? Yeah. Well, so it actually is just, this is a full client-side app. I didn't bother to really build a server. The server is a very simple Express server running in Node that just says return the same page for every URL and let the client app render everything. So this is, like I was saying, built using the components of the app framework, all of them, including Y.App. It's using the advanced or enhanced navigation stuff using PJAX. So when you're clicking on a photo, it's updating the URL, but not doing a full page refresh, and letting the app handle that by showing the photos details. It took about 650 lines of JavaScript that I wrote specific for it. It has a nice responsive design. So the same thing I was showing on my browser is the same code that's running on your phones, and it adapts to the screen size real estate. I actually have all this code up on my GitHub account too. So it's too much to go into, but you guys should all check it out because I think it's a really great example of the power of things you can do with the app framework. And it's not too much code where it'd be hard to get through. It's a nice size application, I think. And just to show the breakdown, the app's basically taking over the full page here. And then we have a place model, which is dealing with rendering. In this case, it was Sunnyvale, California. And then we also have this model list for the photos. And then each of the photos is a model as well. So that's the breakdown of the models here. And then this particular view is what I call the grid view. And it shows just the thumbnails and deals with, when you get to the end of the page, requesting more photos or asking the app to get more photos for it. And then when you're looking at a photo, again, the app's the full page. You still have the place model here. But now you're looking at the photo model and using this lightbox view to look at more details and a larger version of this photo. So we're definitely seeing a lot of potential of things we can do with the app framework. And so looking further out, some of the stuff we're thinking about is how to better deal with data access. Things like sync layers or deal with data binding. So these are all things that we're looking at. Also just expanding our reach on the server, making sure there's as much code sharing as possible, making sure that there's some infrastructure stuff in place like App provides to make it easier to develop single page mobile apps. Also looking at having people contribute view extensions or plugins. Model and view and app are all base-based classes, so they have the whole extension and plugin architecture that they can use. And we just are really thinking that the app framework is meeting people closer to where their problem space is. It's coming up to meet them, and they have this problem. They're coming up with a solution. They want to implement it, and we want to be right there with the app framework saying, OK, you don't have to worry about these infrastructural details. This code will be there to help you structure your application, help you organize your code, help you do some of this boilerplate stuff with managing views and navigation and that sort of thing. And so we're excited about the potential of where this can go. And with that, I'm happy to take any questions that anyone has.
Do you have any plans to somehow being able to use the model and the model list coupled with it, or somehow with a data source?
Yeah, so the question was, do we have plans to couple model and model list with a data source? And I've actually been thinking about that exact thing, and I think that's the right type of solution. And that's some of the stuff we'll be looking at definitely in 3.6 is to, yes, use a data source because it has this abstraction over where the data is coming from, and it would fit in perfectly with like the sync layer of model and model list. So there, definitely that seems to be something that makes sense.
Yeah, and another thing, because obviously a data source is a great tool to put data inside of a data table. And the data table is a great view for a lot of instances.
Yeah, so data table and data source, actually Luke is going to be looking at trying to use maybe some of these the model list and view to help implement data tables since it's such a complex widget. So we're definitely looking at that as well. Yes?
With the new Y.App, so you have all these views coming in, and potentially not all of them are being used right away or whatever. Is there any integration with Loader to say put off loading some of that code that's going to render those views until a user clicked and went into one of them?
Yeah. So the question was, if your application has a lot of views, the views may be like containing widgets and stuff, which is a lot of code that you may not want to front load. So that's a great question, and what you can do is you can use the routing infrastructure within Y.App to basically use a Y.Use call, load in the code you need, and then once all that code's ready, you can call show view on your application and then show that view because all of its code's there. But I think that we're probably going to leave that up to the implementer to use Y.Use instead of trying to re-implement some of those parts of Loader. But that'll definitely be something that we should probably show in the guides so that people see that type of pattern. Yes?
In relation to model, when you see the generic change, when anything changes, the model list, when anything changes inside of the model, do you use any kind of event management? So if you're changing many things within a very short period of time to manage the number of event calls?
Yeah, so the question is, if there's a lot of changes to the model's data attributes over a short period of time, is there anything that we're doing to manage the number of events fired? Probably because you don't want to re-render the DOM 100 times. We don't have that type of like throttling or transaction-based stuff built in per se, but what there is the model's coalescing of the change event. So if you call set adders, which you can pass in a hash of key values of multiple attributes to update, that will only cause one change event to fire. But it's definitely something that we're looking at because there's some more complex things you could do, like a transaction where you start it, you do a bunch of changes, you end it, and then have the changes be, say, rendered. So that's something that we're looking at. There isn't anything in there right now, but it would definitely be great to hear like more thoughts on that type of thing. What you think would work well. In the back?
Are you planning on integrating Mojito or sort of adapting Mojito so that the router can use the same routing mechanism between the two? And personally, I prefer this routing over Mojito's routing.
So the question is there any plans to share some of the code with Mojito and also in particular the routing? So just to talk about the routing stuff is, or the way that it behaves is very similar to Express. And that's what we looked at as like kind of a good way to do routing. I believe that Mojito also uses Express. And I think that there definitely can be some sharing there, and we would probably like both projects to figure out and settle on something that's similar. But I don't know if there's any plans right now on that. So. But I think it's a good idea. Matt?
So the pages are going to have a long life cycle in this when you're using an app framework like this. So I'm wondering if the instances of these objects that you're creating have events or methods that get called so that they can clean up after themselves as they're being destroyed or something to prevent leakage?
Yeah, so the question is around when you have a long-running app, you're creating a lot of objects. There could be a lot of memory usage or leakage. How do you kind of clean up after yourself? So one of the things that is part of the view management for Y.App is dealing with the lifecycle of views, destroying them and creating them. I mean, it's definitely something that we're conscious about because on mobile devices, with the restricted their constraints, eating up a lot of memory would be a bad thing. So I think what we would try to do is make sure that we're doing things right in the app framework infrastructure to kind of clean things up where it's appropriate so that application developers don't have to worry about destroying views as they're showing new ones and stuff. Like in the photo example, as you're arrowing through or going through the large views of each photo, it's creating a new view instance and destroying the old one, and it's showing the new one, destroying the old one. And it's also detaching it from the application in terms of not having its events bubble to the application anymore, and tries to break those types of relationships. Other questions? Yeah.
Is it typical to have one Y.App per document or many?
So the question is it typical to have one Y.App per document or many? I think that the best answer is to say you could go either way. Y.App defaults for its container to be the body of the page, but we've definitely been thinking about the idea of having multiple applications on the page at the same time. And there's, with the current code on GitHub, router, which is the infrastructure that's dealing with the URL changes, you can have multiple routers on the page, and if they have route handlers for that URL, they will respond to it. So the thought is that you could do one app that takes over the whole page, or you could do an app that takes over part of the page, or have multiple applications. So that's definitely something that we want to make sure it does well.
One question, you did mention this. So the router, in a lot of ways, it's all about routing, but it's also a lot of the stuff that you normally think about in a controller, like he just mentioned.
Mm-hmm.
You're having separate controllers or routers that are handling different parts of the app, perhaps on the same URL or the same route, but in different parts of the application doing separate things that might be including modular.
So what is it that you're asking then here? Sorry.
I guess I'm saying that the intent with the router is that it's more router focused, but it gives you the idea you could also use it for controller, have something beyond that that'll handle things you would typically think of going in the controller.
Yeah, so the question is things you would, so the router is kind of doing some of the stuff you would think of a controller doing, especially in like a server-side MVC framework. What about modularizing your application? Where does some of this more controller-like code go? I think it could go in the app and or on the view. It kind of depends. Like our views are these based classes, so they're rich in the sense of what they could do. What you could, you can subclass it, add attributes to it, do all the stuff. So if it makes sense for some of your logic to go there, that's fine. There's no like hard and fast rule there, but I tend to keep it in the app. And the router has this idea of a next route. So you could have the first route, say in the Photos app, when you're looking at the details of a photo, I have two routes that handle that URL. The first one goes ahead and pulls out the photo model, does some stuff with it, loads the large image in the background to make sure it's ready, and then it calls next. And then the next route in that chain, its only job is to just now take the photo, which has been added to the request object from the previous route, and go ahead and call show view and pass it into the view. So that helps like break apart the logical parts of your code that way. So that facility helps a lot. But yeah, I mean, that's where like all these MVC frameworks, it's kind of, depending on what you're doing, it blurs the lines between controller-ish code, where should it live. But yeah, I hope like with the guides and stuff that it helps provide people with at least some ways that it could work out, and we would definitely be excited to see if people come up with better ways too about structuring code. Other questions? No? All right, well, I'll be around, so just come get me if you want to talk more about this. Thanks.